Okay, so we're going to solve quadratic inequalities in this video. Our first example is x squared minus 4 less than or equal to 0. Now from graph transformations, we know that this is a parabola that opens up and is moved down 4. So my vertex is at 0, minus 4. Now it has intercepts at 2 and minus 2. And we see, so we're looking for the x's that make the parabola less than 0, or the part where the parabola is below the x-axis. So the x values that correspond to that is this little interval from minus 2 to 2. So that is the solution to this inequality. Okay, so the next example, we have x squared minus 7x minus 8 is greater than 0. Now, I can pull up my... Oh, hey, I didn't have my microphone. Okay. I can pull up the calculator. And what I'm going to do is graph that function, x squared minus 7x minus 8. Here's our standard view. And so we're looking for when this is greater than 0. So we can see that this part is above the x-axis. So this is the part where the x is, or the function is greater than 0. So we want the x's that correspond to this part, because this is going to be the x's that give us positive values. So I come over here and go up, and then hit the graph. So it's all of these values. But what are those values? If I hit trace and go to minus 1, see that that's the x-intercept. And so for values to the left of minus 1, my y values are positive. So x values to the left of 1, x values to the left of minus 1 make my inequality positive. What about over here? Let's see. If I type in 8, I'm at another x-intercept. And if I go to the right of 8, then my y values are positive. So x values to the right of 8 make my y values positive, which is what I'm looking for. Now another way to do this is to go to the table, and I'm looking for y values that are positive. And so I see that at minus 1 it's exactly 0, and then for x values that are smaller, I have positive y values. So everything to the left of minus 1 and everything to the right of 8. So as I go through my table, there's where I hit 0 again. So between minus 1 and 8, you can see that the graph has negative y values. And then here, after 8, I have positive y values again. So going back, we just saw that from minus infinity to 1 and 8 to infinity, those were the x values where the graph was positive. Now, it might be hard to find some of these x-intercepts. So there's another way, there's a algebraic way to find these x-intercepts. So we set the quadratic equation equal to 0, and we solve the equality. This one factors. So I get x equals 8 and x equals minus 1. Now I sketch a little graph. It doesn't have to be exact or anything. Just kind of a rough sketch with my x-intercepts, and then I look right here. This is a parabola that opens up. And I know that because the coefficient in front of the x is positive. So it opens up, so it's going to go through minus 1 and 8. And so over here I'm above 0, and over here I'm above 0. And then because that is strictly greater than, it's an open circle, which is why I have the parentheses on everything. Alright, let's solve another one. X squared minus 24 is less than 2x. Now, I'm always going to take and get everything on one side of the inequality. And then if I can, well, I should be able to solve it. The question is if I can solve it with factoring, or if I have to use like the quadratic formula. So this is going to factor, and it factors into 6 and 4. They have a difference of 2, and the 6 is going to be negative and the 4 positive. So my two x-intercepts, I take each one. So x minus 6 equals 0. So x is equal to 6. X plus 4 equals 0. So x equals minus 4. So my two x-intercepts are minus 4 and 6. My parabola opens up, so it goes through 4 and 6. And then I look right here, it opens up, and we want the part that's less than 0. And it's also open circles here. And I want the part that's less than 0. So this part is below the x-axis. So I color that, and that's going to be my interval, minus 4 to 6. Now if I go to my calculator, I get, so I'm still going to do x squared. I'm going to bring the 2 to the other side, minus 2x minus 24. I can graph it. And there's minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5, 6. So there's the minus 4 and 6. But if I go to the table and I start going through the table, there I see I'm at 0. And now I have all of these values that are less than 0. And I still have all these values less than 0 until I get to minus 4, and then I'm positive again. So I can tell, in this case, because my x-intercepts are integers, that that it's from -4 to 6. So that verifies the answer that I got algebraically. Okay, last example. 2 minus x squared is less than or equal to 0. Alright, so I'm going to take the 2 minus x squared and set it equal to 0. 2 has only factors 2 and 1, and 1 has factors of 1 and 1, so I get x in each spot. Now I want to arrange this where the larger value is negative. So that makes it, when I take 2 times x, that needs to be negative, and this one will be positive. Equals 0. So 2 plus x equals 0 means that x equals -2. And 1 minus x equals 0 means that x is equal to 1. So now I sketch a rough sketch. I have my intercepts marked at -2 and 1. It's going to be closed circles because it's less than or equal to. Now this parabola opens down because its coefficient is negative. So it goes like this, and the part where the graph is negative is to the left of -2 and to the right of 1. So I would write my solution as -2, minus infinity up to -2, square bracket, union 1 to positive infinity. And that would be my answer in interval notation. Alright, so those are all the examples that I had. If, let me just say that if your intercepts come out to be integers or fractions, it's not so hard, but if you could have intercepts that are irrational, in which case you would need to do like the quadratic formula or something to find the exact values, which is what the computer will be looking for.